it's me, Lego Man. So this week is a very special week because we are going to be celebrating Computer Science Week. Yeah, can anybody say awesome? Everything is awesome. Yeah, I'm so excited, guys. So we are going to be celebrating Computer Science Week by doing an hour of code. You guys are going to have so much fun. I think you're going to love this so much. But I just want to tell you, please do not love this more than you love Legos, okay? Legos still need to be your number one toy that you love, okay? And game that you love to play. Don't love it more than the hour of code, okay? Lego Man, good morning, everybody. I think you're just getting a little bit, carried away here. Oh, sorry, guys. I know I always get carried away talking about Legos because if you haven't noticed, I'm a Lego. So all I ever do is talk about Legos. I know. All right. Well, let's get started because we have a lot to do today with the second graders. And welcome everybody to our technology class. And yes, Lego Man is right. This is Computer Science Week. And if you remember back to first grade and kindergarten, we always celebrate Computer Science Week in December. It's usually the second week in December. And schools across the entire United States, they all celebrate by doing an hour of code. And it's a little bit different this year because we're not together in the technology room, right? And so instead of all of us being on our own computers, doing the hour of code, I'll be sharing it here. And then I have a special activity that I'll be sending home that you guys can work on. And that will be your assignment for the hour of code. Okay. And I also want to mention that when we come back from the Christmas break and we move into the third quarter, we will be moving into using Codeorg. So if you remember that program from kindergarten and first grade, that's our computer coding program. And so we'll be using it and you will be getting your own account on there. Okay. So this will be where you can go in and you'll be able to do all the coding lessons. But let's just watch a little video before we get started about the hour of code. And then we're going to get started on the hour of code. Okay, guys, hang on.
We learned a lot in 2020. A lot.
Like how to navigate video meetings.
And that PJ bottoms can count as a school uniform.
We learned new words and phrases.
Like social distance.
And essential workers.
We learned it's okay to be lonely sometimes.
Or tired.
Or discouraged. We've learned that injustice persists. But so do heroes.
And that more than ever, we're all connected.
But the digital divide is as wide as it has ever been.
We've learned that to build the future that we want, computer science is more important than ever.
So we keep learning.
We learn computer science to predict forest fires and earthquakes.
And to help design vaccines that fight disease.
We learn computer science to connect with each other.
To make art and music. We learn computer science to make sure no one gets left behind.
Because building a brighter future will take all of us.
Hey, this is Hill Harper, and whether you're in the classroom or learning from home, doing an hour of code is a great way to learn computer science. Right, Pierce? Hour of code! Yeah!
So welcome everybody to an hour of code. And I hope you guys are going to have a lot of fun. So what we will be doing for our hour of code is I will be going through the entire hour of code with you. And then I have a special activity that you can work on. And so I want you to pay attention to the code that we will be using, and I'll be walking you through every level in this. And so guess what this is called? Outbreak. Code your own simulation. And so this is all about an outbreak in Monster Town. And it's very similar to what we have been going through with COVID-19, right? Because that has been an outbreak that has been spreading. And so it's super cool that the theme of the Hour of Code this year was really so similar to what we've been going through. So the little monsters, they understand you guys, okay? All right, so I'm going to read you guys the story about Monster Town. So it says, welcome to Monster Town. Monster Town was usually a happy and healthy place. The monsters of Monster Town loved to wander around to visit their friends. So there they are, all the little purple monsters visiting their friends. One day, one of the monsters started feeling sick. The monster had caught a virus. A virus is a tiny germ that can make you sick. The other monsters were not too worried. They kept visiting their friends. So look, there's one little sick monster, the pink one with the little yellow spots on it. And all the other monsters are still healthy and they're still going and hanging out with their friends. Soon after, 2 more monsters got sick. It was the same virus. It seems they got the virus from their friend. Uh-oh, it's spreading. The virus slowly spread to other monsters who were nearby. The healthy monsters began to worry that they were all going to get sick, and the sick monsters began to worry that they were going to give the virus to everyone else. Uh-oh, look, the virus is spreading to more and more monsters. Stopping the spread. Fortunately, after studying the virus, the neighbors of Monster Town made an important discovery. They realized that they were less likely to spread the virus if they wore masks over their mouths. With face masks on, sick monsters were less likely to give the virus to healthy monsters. So look, now they're all wearing masks, just like you guys. Just like me. I'm wearing a mask. Do you like it? Lego man. What will happen next? Today, we are going to write code to create and run our own simulation of the virus outbreak at Monster Town. A simulation is a computer model. So we can use this to help us to make predictions. That means we're guessing about what we think might happen. Like, for example, how quickly will the virus spread? Will everybody get the virus? How will the face mask help us? So we're going to use code to answer those questions. Are you guys ready? I'm ready. Let's go. All right, let's go. I'm going to press continue. So I'm just going to remind you guys about code.org if you forgot. So welcome to code.org. This is our workspace. And so if you notice, there's blocks here, right? And so computers, they do not speak English, right? They speak a special computer language. And there are hundreds of different computer programming languages. And when a computer programmer types in code into the computer, they have to know the right language that the computer speaks. And so for us, since we're just learning, we're using a language called Blockly language, and they look like Lego blocks. Yes, because they knew that Legos were the best, so they had to make them into Lego blocks. I don't think that's why, but I think it's because blocks are easy to understand. So every block tells you what to do. When we hit the run button over here, whatever our blocks say is going to happen over here in the green area. So we can connect blocks all inside of this workspace. And the blocks will then tell our computer program what to do when we hit the run button. So Codeorg is really amazing because it's for your guys. It's the age of for you guys, right? And it gives you pretty much step by step. So I'm going to read through it and then I'm going to do it and you guys can follow along. So it says today you're going to write code so you can run your own simulation of the virus at Outbreak at Monster Town. First, we will bring Monster Town to life by creating sprites to represent the monsters. Write your code in the workspace, then press run to see your simulation. So it wants us to make 10 healthy monsters and 1 sick monster. It also wants us to make the size of the monsters 50, and then it wants us to make them begin wandering around. So all of my code, all of my blocks are inside of these different categories. So a sprite is a character in the game. And these characters are monsters. So I'm going to click the block that says make 10 new monsters. And we want the purple ones. These are the healthy ones. And I'm going to attach it on. I'm going to go back into sprites and I'm going to click the block that says make one new sick monster, the pink one with the yellow spots. Then I want to go into actions and I want to set all sprites to size 50. And then I want to go and make all of the sprites begin wandering around. So now I'm going to press the run button and all of the code that's attached here in the workspace is going to actually happen over here. So here we go. Ready? Watch. There's all the monsters and they're wandering around. Woohoo! Great job coding. All right, now we're on level 3. Level 3 says, uh-oh, one of the monsters caught a virus. When a healthy monster touches a sick monster, it becomes sick too. We're going to make an event. So when 2 sprites touch each other, we're going to make the healthy monster turn into a sick monster when it touches the sick monster. So I'll show you how to do it. So now we're using these blocks right here. When, it says when a healthy monster touches a sick monster, we're going to change the costume. So remember, the sprites wear little costumes. So if I press this blue button here, I can now change my purple healthy monster into a pink with yellow polka dot sick monster. So let's see what happens. Watch over here. I want you to watch the sick monster. Whenever he touches a healthy monster, let's see what happens to them. Let's see. Oh my goodness, the virus is spreading. I see more of the purple monsters are starting to, they're turning pink with yellow spots. They're getting the virus. They're too close to each other. They're not keeping 6 feet apart. Oh no, they're not keeping 6 feet apart. Did you see how quickly it was spreading? The sick monster touched one and then it got sick and then it touched another one and then it got sick and it started spreading around, right? Stopping the outbreak with masks. One way to slow down the outbreak is to wear a mask. It says monsters with face masks will be unable to get the virus or give it to others. To make something happen when a monster is clicked, you can use a new type of event block, the when clicked block, and then we can change the costumes. So for example, when we click the healthy monster, what do we want to happen? Let's go into actions and let's get a change costume block. Now we're going to change the healthy monster into a healthy monster with a mask. So we're changing the costume into the one with the mask. Let's do the same thing with the sick monster. When we click on the sick monster, we're going to change the costume. So we're using our when clicked block. And it says when a sick monster is clicked, it changes the sick monster into a costume with a sick monster with a mask on it. So now you have to be really, really quick with your mouse because I'm going to have to quickly click on these monsters and get masks on them. Are you guys ready? Okay, here we go. Oh my goodness, the virus is spreading. I need to quickly get masks on everybody. Oh, I need to click. They're getting masks on them. Oh no, oh no. Does everybody have a mask? Okay, I got masks on most of them, but the virus did spread to a few of them because they didn't have their masks on. Okay, so it says outbreak, thinking like a scientist. So scientists, if you guys know, they study the viruses and they try to figure out how to keep people safe, right? And so what we've been doing is creating simulations. This means we're using computer code to help us see what might happen if we put our masks on, if we don't put our masks on, right? If we're touching each other, if we're not touching each other. And this is what scientists do. They try to solve problems and test new ideas, and they use computers to help them, right? So that way, then they can go and use it in the real world with us. So even when you write code yourself, right, it's impossible to know exactly what will happen when you press the run button. So we don't know because things might happen differently every time you press the run button. And that's kind of how it is in our world, right? We can never really know exactly what's going to happen, right? Things can happen differently because we're people and we have choice, right? We have free will. Trying to write down your observations can be helpful sometimes, right? So for example, we can predict, we can try to guess, like if we added twice as many monsters, what do you think would happen? Do you think the virus would spread quicker?
I think so, because then you would be touching each other and there'd be so many of you and it would probably spread quicker.
Interesting, it could be. What if the monsters moved really slow? What do you think?
It might be harder to get the virus because they're not touching each other as quickly because they're moving slower.
Could be, yeah. Is Monster Town like the real world? Well, it's similar, but it's never going to be exactly like the real world, right? And so whenever they use a computer model or a simulation, it's just trying to help them to learn about, oh, if I do this, what might happen, right? But it will never be exactly like the real world. But we can model a lot of different things using computer programs. And hopefully this is getting you guys to see that scientists have been using computer models throughout all of COVID-19 to help them figure out the best plan for everybody, right? And what would be the safest way to keep the most people from getting the virus. And so it can be very, very helpful to be able to use computer code, right? To try to predict or guess what might happen and try out different things. So we're now going to try a few different things with our code. So I'll show you guys. So new monsters are moving to Monster Town. What will this mean for the outbreak? We're going to use the simulation to figure this out. So we're going to change how many healthy monsters there are, and we're also going to change the size of them, and then we're going to run it. So I'm going to make, let's see, we have 10 right now. Let's make 25 new monsters. And then I'm going to change their size to size 10. So I'm going to make them really small. So now we have a lot of monsters, but they're very small. So let's see what happens. I'm going to run it. So I see the sick monster right over here in the upper right-hand corner. It hasn't infected any. Oh, it infected one monster. One, let's say, 2, 3. So it infected 3 monsters. Okay, now I'm going to make 5 new monsters. And I'm going to make them really big. I'm going to make them size 75. Now let's see what happens. Let's see if the virus spreads quicker or not. So they're bigger, and it's easier for them to touch each other. So it looks like the virus has spread pretty quickly. Every monster got the virus. So why did that happen? We had fewer monsters, but they were bigger, meaning that they took up more space. And so they were touching each other quicker because there was just more body to them, right? So hopefully this is getting you to see how we're using a computer model to figure out what might happen, right? So like, what if I added 75 new monsters and I made them all size 50? Let's see what would happen.
Oh my goodness! They are not social distancing. Look at them. They're like all right on top of each other.
Well, what do you think is going to happen?
I think the virus is going to spread so quickly.
Oh my, look at this. Look at that.
Oh, the virus is spreading everywhere. Oh my goodness.
Now, what if, let's see if we can come up with a model where they're all going to put their masks on. So maybe I'll go back. I'm going to make 10 new monsters. I'm going to make them size 25. Now I'll make them a little bit bigger. Let's keep it at 50. Okay. So now what I'm going to do is when I hit the run button, I'm going to quickly try to put masks on them and see if this helps to stop the spread. Oh my gosh, I need to, oh no, let's see if it worked. I'm trying to mask them up. And so I was masking them up and it was helping to stop the spread, but I have to be really quick because the program runs pretty fast. But hopefully it's getting you guys to see that I'm changing around all the things. I'm changing around. And that's what scientists do. They're like, if we have this many people living in a certain area, what might happen if they all come together and they're not wearing masks? You know, will all of them get the virus? What if they're keeping their distance and they're all wearing their masks? Will fewer people get the virus? Right? So they're using computer code to help them figure out the answers to these questions. So then they can go and they can tell the people, listen, we looked at our computer models and we really believe that if you keep away from people and you keep your mask on, you won't get the virus. You'll be safe, right? And then they help to educate people. So there's a little bit more to this, which I might show you guys, but the code gets a lot harder because this is meant for a lot of different ages. But I'll show you because I think you guys are super smart. So the next thing that we can add into our code is we can start to code the program where when a monster's sick, it can begin recovering, meaning that it gets better. So it says monsters can start to feel better on their own. Sick monsters that begin recovering will automatically change back to a healthy monster after some time passes. Let's add code to the simulation to make all sick monsters gradually recover. So we're using a new block. So we're going to the when touches and they become sick. So we want this one. And then what we're doing is we're going to add this block. This one where it says Sprite begins recovering. And we're going to add that code right there. So I'll tell you what the code says. When a healthy monster touches a sick monster, the healthy monster becomes sick. But after some time, it recovers. Okay, so you have to watch carefully on the screen. Pay attention to the pink monsters with the yellow dots and watch them. They're going to turn purple after a few moments. So there we go. Let me put some masks on some of these. So some of them got sick. There they are. Now let's see. Watch and see when they turn back to purple. And you'll see after a few, that one just turned back. See? That one just turned back. So they're turning back to purple, meaning that they're getting healthy again because they're recovering from the virus. So we just added the code to do that. Okay. I'll just talk about it with you guys for a few minutes. This is talking about, and I know you probably haven't learned about this yet, and you'll learn about it when you get older, but it's something called chance. We call it probability. So this is something that's really important for scientists to use because there's a little chart here, which I think is really helpful. I'll see if I can show it to you guys better, but it talks about face masks, right? So it tells you your chance, your percent chance, your probability of getting sick. If there's a healthy monster and a sick monster and they both do not have masks on, your chance is very high, 90%, almost 100%, meaning that you have a pretty high chance of getting the virus. Now, if the healthy monster has a mask on and comes near the sick monster, still a pretty high chance, 75% chance that they might get the virus. Now, if a healthy monster is not wearing a mask, but a sick monster is wearing a mask, there's a low chance, 25% chance that the healthy monster will get the virus. And if both of the monsters have masks on, very low, only 10% chance that the monster will get the virus. So we can use code to add in chance, meaning that we can tell the computer all of these different, we call them scenarios or options or choices, that if any of these happen, we can tell the computer, if two monsters touch each other and they have no mask, 90%. So it'll quickly get sick. If 2 of them touch each other, only 10%. So only make 10% of them get sick. And the computer will listen to those rules, and then it will do that in the program. Okay, let me show you guys another thing in here. Vaccine. So they made a fun little thing in the code where what you can do is you can give the monsters vaccines. And then what happens is when the monster gets clicked and it gets vaccinated, then if it ever touches a sick monster, it won't get sick. So you can also tell the computer, okay, computer, I want you to pretend that 50 monsters got the vaccine. And so then the computer is going to make 50 monsters get the vaccine. And then what we're going to do is see, does that help to slow the spread? Because if more monsters get the vaccine, then maybe none of them will get sick and it will stop spreading it around, right? So we don't know. But again, the computer code can help the scientists to predict or guess and figure out what might happen if they use vaccines, right? Something else that's really fun, I'll show you guys really quick with the code, is you can code messages. So you can actually make your program say something. So for example, maybe at 5 seconds into the program, you want to tell the monsters, mask up. Oh, oops, I'm not typing in there. Mask up monsters. Monsters. And then let's watch. Ready? So watch over at the screen. It's going to come up. Well, let me start putting my masks on. Don't spread the virus. Don't spread the virus. Put your masks on. And look, mask up monsters. So I added some text or some writing to my code. And then the last part of the hour of code is just a fun time where they just let you have free play with the code. But you guys, we're going to be using our coding curriculum pretty soon in the coming months, and everybody will get their own Codeorg account. So today was really just an hour of code to celebrate Computer Science Week and just celebrate learning about this and just to have fun, because this Outbreak Simulator was a really great way to learn about computer code and computer science in a way that's something that we could all relate to, because we all know about this. We're going through it together, right? So let me show you guys what you are going to be working on. So everybody's going to get one of these sheets, and look what it says. I'll make it a little bit bigger. It says, help the monster get to the mask. Stay away from sick monsters. So look, the little pink ones with the yellow dots are the sick monsters, and there's your healthy monster. He needs to get over to his mask. And so you're going to use an algorithm. If you remember an algorithm is a list of steps to follow to finish a task. Yeah, so it's your list of steps. And our algorithms are the arrows. We have move 1 square right, move 1 square left, move 1 square up, move 1 square down. And so you are going to use those in the boxes here to write an algorithm for this monster to get over to the mask, okay? So let's look at this here and think. There's a lot of different ways he can go. So let me see, I can write on here in a minute. Let me get my little pen here so I can write on here. He can go this way. So he can move this way, he can move this way, and then he can go up. So I'm just making a possible way that he might be able to go to get to the mask, right? So he can move 1 square right, move 1 square right, move 1 square up, move 1 square up, move 1 square up, move 1 square right. He can do that. He can also go this way, right? He can do move 1 square up, move 1 square up, move 1 square up, then move 1 square right, move 1 square right, and move 1 square right. So he can go any of those ways. Do you think he can go move 1 square right and then move 1 square up? What would happen if he did that? He would get the virus! Don't go that way! Okay, guys, you need to think this through. Keep your monster safe and healthy. Get your monster to the mask right away. Yes, so you guys are going to use this to write your algorithm in these boxes below. You please use the the arrows and draw them in the boxes and write the algorithm. But please make sure that your healthy monster does not touch any of the sick monsters and that he gets to the mask safely. Okay, so that's your fun activity for this week to celebrate Computer Science Week. So have fun completing this, and then you can send in your completed work next week. And happy coding, everybody. I hope you guys had a lot of fun, and we will see you next time. Happy Lego Day. No, it's not Lego Day. Happy Legos are the best. Don't ever forget that, okay? Bye, guys.